Hello and welcome. In this brief tutorial, I'm going to talk about accuracy and precision. Basically, you've seen these maybe targets before where they show little clusters of your data points. They're all in the middle, they're all off to the side, or there are certain amounts of statistical scatter that could be either systematic or random. We don't ever call anything human error because we're assuming that, we're not making mistakes. Gross, big, huge mistakes, but that does happen from time to time. Now, let's talk about a situation on the very left where you have both accurate and precise data. This is the ideal, all right? Let's say you have water. You've correctly grabbed distilled water that's really pure. You've controlled all of the environmental factors that could affect the boiling point. And you measure the boiling point 3 times and you get 3 different numbers and you average them and you get the correct answer. All of your data is within the error of the instrument you're using, and so this is both accurate and precise. We say it's accurate when the average is the correct value, and we say it's precise when there's very little deviation or statistical error in your data. Okay? Now let's look at a situation where you have accurate data, but it's not precise. This is a common situation where students measure the temperature of water, for example, that's boiling, and they get 3 different answers, maybe a little low, maybe a little high, maybe right on the mark, but either way, the average comes out to be 100.0. So we say this is accurate because you got the right answer at the end of it, but it's not precise. There is significant random error, okay? Some is high, some is low. It all averages out. The error averages out to give you the net result of the correct 100 degrees Celsius. So that's accurate in terms of you getting the right answer, but not precise in terms of a little bit of scatter in the data. Now let's look at a third situation where it's not accurate, but it actually is precise. So for some reason, the instrument is malfunctioning, or perhaps maybe even there's something wrong with the water, okay? So anyways, let's take a look. Maybe you measure 3 different temperatures, and they're all pretty precise. You always get the same number there, but when you do the average, you get 97.4, and that is not correct, okay? We don't ever say this is human error because usually in chemistry, you would go back to your calculator and you would punch it in again and you would make sure that you're doing things correctly, okay? You wouldn't write down a wrong answer without going back and redoing the experiment and checking on things, okay? So this is very precise in terms of you always getting the same value within, statistical error. But it's just way off. We know the boiling point of water should be 100. This is 97.4, which is a little bit like a different substance or something, or what went wrong there, okay? So this is systematic error. All right, your fourth possibility here is very poor data, and this is when you do not have accuracy and you do not have precision, okay? So let's say you're measuring the boiling point of water, you get 90.4, maybe you get 58.3, maybe you get 74.2. Numbers are all over the place, way outside the plus or minus 0.1 or 0.2 degrees Celsius of the thermometer, and you get an average, but it's meaningless because your data is so scattered. There's no reliability in that at all, okay? It's definitely not averaging out to 100 degrees Celsius. So this in a nutshell gives you the 4 different scenarios, and this gives you a summary as well. The first case, we saw accuracy and precision. The second case, we saw that the data was accurate, but not precise, okay? In the third little target, we saw how it was precise, but not accurate. And in the fourth target, we saw it was not precise and not accurate, okay? Now, in the first case, there is no error of any type, okay? Either random or systematic, okay? In the second case, we saw that there was correct accuracy, but the precision suffered. Whenever the precision suffers, it means that you have a little bit of random error, okay? Maybe the thermometer is misbehaving, the battery's low, or something like that, okay? In the third case here, we have a It should be an X there for random error. There's very little random error because all the data points are all clustering on the same location, but there's a lot of systematic error, okay? You're always aiming off and you're always getting something over there. So systematically, your gun sights are is wrong, okay? Somehow it's targeting the wrong location, okay? So something's going on there systematically, and usually you can identify what that is in an experiment, okay? And then in the fourth system, we have just everything wrong, okay? So that in a nutshell is kind of what's going on here with the accuracy and precision. I hope this helps. Please like, please subscribe, and have a great day, everybody.